Pulse code modulation. Pulse code modulation is used to convert analog signal into digital signal. Before that, we know that why you are going for digital signal. The digital signal and is used to transmit the signal with less distortion. So here you can see this in modern communication systems, analog signals are transmitted digitally and the distortion is very less. That is the reason we are going for digital signal transmission compared to analog. And within that there are different modulations are there. In that is analog modulations and digital modulations, PAM and PWM, pulse amplitude modulation and pulse position pulse width modulations are analog modulation techniques. PCM, pulse code modulation, and DM, delta modulations are digital modulations, digital modulation techniques. Here, that is the reason we are going for, compared to analog modulation, we have some advantages to transmit the signal. And generally, if you are, if you said, for example, hello, so this should be converted into, first need to convert it into analog. In communications, the physical signal is converted into analog. So this is the analog signal, hello equivalent signal. If you want to transmit directly, then using analog modulations, it is analog transmission. But if you are transmitted directly after modulation, after amplitude modulation or analog modulation techniques through wire or wireless, so you may get more distortion, you may lose the signal. So that's why we are going for, that is, this analog signal is need to convert it into digital signal transmission. So that's the reason we are going for, that is pulse code modulation. So here you can see this, the types of modulations, analog modulations, that is, one is PM, pulse amplitude modulation, pulse width modulation, and pulse position. So now the digital pulse modulation techniques are, that is PCM, pulse code modulation, and one more is delta modulation. So here you can see this analog signal. For example, as I said, this is the equivalent for physical signal is hello. This is converter. After conversion from physical signal into EM wave, this is an analog signal. If you want to convert from analog to digital, then by using sampling and quantization, we can convert, that is, analog signal into digital. So first, this is the sampling is used to convert it into samples. So this is the PM. Here we can generate, that is PM signal, pulse amplitude modulated signal. Just you can see this here. I will show this. As I said, this is the hello equivalent signal. This is the physical signal, and this is, by using sampling we can convert it into, that is, this signal is converted into sampling. So this is the sampling, that is sampling output, PM, pulse amplitude modulated signal. So this is the pulse amplitude modulated signal. After sampling, we can get the pulse amplitude modulated signal. And here, this signal is, again, by using quantization, we can convert it into digital signal. Here, after quantization, here you can see this, every sampling is converted into equivalent digital code. For example, this sample is having equivalent encoding, that is it will give, for example, this is 101, this is 110. Like this, infinite number of samples are predefined by the, that is, digital encoding. Predefined. If you take any audio or any video signal, the equivalent samples, the samples are having, that is, equivalent encoding values. So this is the after conversion, after giving a, after encoding, this is the output. For example, this is the output for signal. So you can say this is an physical hello signal, just assumption. You said hello, you said hello here. So this is converted into, that is, electromagnetic wave, that is this is a EM wave. After conversion from physical to EM wave, electromagnetic wave. So but if you want to transmit for long distance communication, of course we need to go for modulation, either analog modulation, if we want to transmit analog signal. But here I need to go for the digital communication, digital transmission. So that's the reason we need to convert this analog signal into, digital. For that we need to go for sampling. The original signal is sampled by using sampling, so we can convert it into samples. And after sampling, these samples are, we are going for quantization. We have different types of quantizations we will discuss, and here this quantized levels are having, that is, equivalent to digital encoded value, predefined value. Each and every signal, infinite number of samples are having predefined its equivalent encoded value. So that code is, this is the digital signal. After this, they can transmit a digital signal. So this is about basic pulse code modulation. The advantages of digital communications, as I said here, uh, here noise is very less and distortion is very less compared to analog transmission. Noise is very less. That's why we are going for digital communication and digital transmission. And we can say this repeaters prevent accumulation of noise along the path. That is the reason we are going for the digital communication. Hardware implementation is very easy compared to analog. It is very difficult to transmit analog directly. Hardware implementation is very difficult. That's the reason we are going for digital communication transmission. Very flexible compared to analog, and noise is less, interference is very less, and that's the reason error rate, even error rate is also very less compared to analog. And multiplexing is easy in digital communication compared to analog. We can multiplex if you go for more number of signals. If you want to transmit, for example, here ETV is there, Gemini is there, TV9 is there, different signals are multiplexing and transmitting through a single cable wire, coaxial cable, or else even with wireless transmission also, it is very, multiplexing is very easy compared to analog. That's the reason we are going for, that is, digital communication transmission. And elements of PCM system we'll explain in the next class. But here, why, what is the pulse code modulation? Pulse code modulation means analog signal is converted into digital by using sampling and quantization. We are converted into digital. Sampling means the original signal is sampled and the sample value is having its predefined digital equivalent signal. Using that, we are converted in analog signal into digital. Thank you. If you have a doubt or suggestions, send to me.